Howdy folks, so we are back and we're going to continue on with section 9.1. We have some of that basic terminology about lines and rays and all that stuff, so now we're going to start putting some of that stuff together and looking at some different objects. So the next thing we can look at are angles. So angles are formed in a lot of different ways, but two common ones are listed here. So it says angles are formed if two rays have a common endpoint or if two lines intersect. So you could have something that looks like this. And so the angle is kind of like the space between the two rays. Or if you have two lines intersect, so you could have something that looks like this. And in which case we got a lot of angles. So we got four of them, 1, 2, 3, 4. So in the case of the first example here, the two rays are called this angle sides while the endpoint is called the vertex. So this pivot point here is the vertex. And again, these are the sides. Well, I shouldn't need a S on there, but so we got one side and we got the other side. Now, as far as how we can determine between different sized angles, so again, think of that angle as being, or that pivot point being able to allow you to open and close that angle up. So how do we get, or how do we measure different sized angles? And there's a lot of different ways, but we're going to focus on one, just one that's the most common one. So to measure the size of the angle, we could do so based on the amounts of rotation. So if we kind of kept one of them fixed and then we started rotating the other one around, we're going to get different sized angles. So the numerical value of 360 is used to define one complete rotation. So again, if I went all the way around into a complete circle, back on itself, then that would be 360 units. What are those units? They're going to end up being degrees. So 360 degrees is going to be one complete rotation around, as stated here. Now the units for degrees is kind of like for temperature. So you're still going to use that like raised little circle next to your numerical value there. So 360 degrees is one complete rotation. So that's our starting point. Now, if we wanted to look at different size ones, we can kind of chop that up mathematically speaking. So if we broke it down to 1 degree, that would automatically mean that we have 1/360th of a complete revolution or a complete rotation. So it's just a little bit of a angle on it, not much. So using this relationship, we can determine various special angles. So there's a few special ones that you should be familiar with. So now a 0 degree rotation was pretty boring, but we could draw it. So essentially it would look something like this. So technically here, it doesn't look like it, but there's two rays that are right on top of each other. They're so close together you can't tell them apart. So we got ray BA and ray BC. They're right on top of each other. Maybe I should go this way. They're right on top of each other and you can't tell them apart. So that's the first one. Boring, right? The next one, if we go straight across, is 90 degrees. And 90 degrees is going to be 1/4 of a complete rotation. So that's going to look a little bit more familiar to you. So if we have our ray AB, or excuse me, BA rather, and that's going to go straight across. And then we started to rotate BC straight up. That's going to end up looking something like this. Now, how do we know that it's not off just a little bit one way or the other? How do we know it's perfectly straight up and down to give me that 90 degrees? Well, mathematicians thought of that and they said, well, let's put a little tiny square in the corner and that's going to be our indicator that it's really a 90-degree angle. So anytime you see that little square in the corner, that kind of forces it to be a 90-degree angle, even if it's drawn off a little bit. So that's going to be a special one you should be familiar with. The next one is 180 degrees. And you can see that that's going to end up being a half of a complete rotation. So what's that look like? Well, again, pretty unoriginal. But if we have our ray BA again, still starting off, we're not moving that one, we're just moving BC around. So it's going to go pointing straight across the other direction. So it'll look just like this. So there's 180 degrees. And like I said, here was 90. So again, it is important because it forms that straight line. So it is going to be a special angle we're going to come back to now and again. Now the next one after that, well, it's 3/4. It's 270 degrees. Now, you're probably saying, well, doesn't it look pretty much the same as that? And the answer is yes. Now, technically speaking, it does look a little bit different, and now let me show you how. So let's first draw our ray BA. But now, if we want to go 3/4, so we got a quarter, a half, and 3/4 is going to be pointing straight down. And there's C. And so this angle on this side is our 270 degrees. Now, what does that force this angle in here to be? Well, yeah, you guessed it. It's got to have to be a 90-degree angle inside. So really 270 is not that special because you can kind of use a 90-degree angle to describe it as well. At least the picture. It looks pretty much the same. So you're not going to see too much with 270 degrees as far as problems. And the last one is kind of boring too because it's 360. And you're probably saying, doesn't it look the same as the 0? Well, yeah and no. Same type of thing. You got your one direction here, still got B here. Now, one of the ways they try to make it look a little different is they reverse the letters around. And then they'll also put kind of a swoop all the way around here. So there's our 360 degrees. So we got that complete revolution all the way around. And it's so much that it's a little bit underneath, it pushes the A up top and the C is now on the bottom instead of vice versa. So that's kind of a way to think of it. But is it really that special? Not really. So out of all of these, which ones are really the most important? I would say the 90 and the 180. Those are the two biggest ones you want to be familiar with. So let's explore those a little bit more, and then we're going to see some examples. Now, some of the names that you might be familiar with or you might have heard over the years. So a 90-degree angle is also called a right angle. Why is it not a left angle? I don't know, but it's a right angle. And then 180 degrees, well, what's it look like? It looks like a straight line, right? So they call it a straight angle. Now, again, those other names are not absolutely necessary for you to learn or know, but if somebody does reference it, you should have an idea in your head what it looks like. That's the biggest thing. So there's a couple other names. Now, what about angles in between? Aren't those special, or do we need to kind of categorize those? And the answer is yes. So the first category would be angles between 0 and 90. And if it's between 0 and 90, they're going to be acute angles. So they would look something like this. You're going to have, just a skinny little angle. But remember, it can get all the way up to 90, not including though. So it could look almost like a right angle, but be just a shade less than 90 degrees. And those would all be in the same category of being acute. Now, the next group would be between 90 and 180, and those are considered obtuse. So, whoop, there goes my lead again. So an obtuse angle would look something like this. Again, it's definitely more than a quarter of a rotation, but less than a half of a rotation. That's that middle ground that we're looking at. So same thing. It could be just a tiny bit over 90 degrees, and that would be enough to make it obtuse. So there's quite a wide variety of angles you could have in there. Now we're going to come back to these terms for some of the applications later on, so just keep that in mind. Don't forget those. Now, the last example I want to, or the last term I want to familiarize you with is called vertical angles. So, opposite angles formed by intersecting lines are called vertical angles. Okay, well, so let's draw two intersecting lines. And now, so it says opposite angles. Opposite angles. So if I was looking at this angle up here, I would also want to look at this angle down here. So now let me just number them for ease. I'm going to say this is 1, 2, 3, and 4. So 1 and 3 are considered vertical angles, but 2 and 4 are also. So those are also vertical angles. So angle 1 and angle 3 and angle 2 and angle 4. So you can kind of see I've already introduced a notation. So this is the symbol for angle. Now, I should have done it in the last video, but I didn't. I'm going to do it right now. If we have an angle, it's going to be able to be described three different ways. If you got letters in there, which hopefully you do, I'm going to put some letters in there right now. You got A, B, and C. I could describe this angle three different ways. So the first way is based on its vertex. So angle B. And again, it's kind of like a less than symbol, but it's flat on the bottom. So don't draw it like a less than symbol. Make it flat on the bottom. That's the proper way to do it. So I could describe this as angle B. I could also describe this as angle ABC. And I could also describe it as angle, whoops, not angle whoops, angle CBA. Now, what's the difference? Does it really matter? Well, three letters are usually the preferred method, especially when you got more than one angle in a diagram. But if there's just one angle, one letter is enough. But like I said, I would lean towards using three letters. And the one important thing you'll notice is look at where the vertex is located. The vertex is always that middle letter. So that's why this is angle ABC or CBA. All right, so keep that in mind. All right, I'm going to do one example in the next video. Psych. See you in a minute.